Well, welcome to the future of space. I'm sure there's no one in the audience who doesn't know that DARPA was created because of the satellite Sputnik. In fact, if there is, I'd like you to raise your hand. DARPA has had significant activity in space, which seems to oscillate over time. In fact, it's about every other 10 years, if you go back through the history. Now, it always has something in space, but about every 10 years it has a major programs in space. I mean, up to a lot of money, if you want to judge that, $500 million a year or more. And we are in one of those cycles now. Back when I came into DARPA, the Secretary of Defense, Donald Rumsfeld, handed the DARPA director to be. He said that space was important. And this is in the year 2001, by the way. And he gave me a copy of the Commission on Space, which he chaired. Well, I kind of figured out that space was important. And I did read that commission report. At that time, in order to talk about space, we broke space up into several areas. And if I can have the first slide. There it is. So we broke up space into 5 areas, which access, you had to get there if you were going to be in space. You kind of had to know what was there, situational space, active and passive sensing of space from space or ground. And when you were there, you remember we're a military organization, we were providing space-based support to the warfighter, and also space mission protection was another activity, protecting our assets that were there. And then another one was space mission denial, keeping somebody else from going to space. And these were the 5 areas that we had starting out in 2001. I'm just going to give you a few examples of what we did. So can I have the next slide? On access to space, that was a problem, as it still is today. It took months to send anything to space. And a lot of it was because of the ranges. To get on a range and get through all the problems of time and in a slot, it really took sometimes months in order to get a date, and then even more time than that. So we went and tried to find techniques where you could launch a missile any place. And we had several techniques. One was a small booster called Falcon 1. It was I guess the birth of SpaceX, right? I don't know what you were called then. You weren't called SpaceX at that time. We were. Yeah. Another one was to launch it from an airplane. And we actually put a booster mock-up in the C-17 and dropped it out the rear end with a parachute on it. And that C-17 said, the guy said, we didn't even know it left. And then others were just other kinds of techniques. Well, the odds of this all happening the way we planned it were rare, but it happened. And Dave Honey, who was doing the briefing, started briefing, and he went right to the Falcon program and said, this is launching from an island in the Pacific. And this is totally, they actually went there, took the island, cleared a place to put the booster, and it really was a place which had no infrastructure. So the launch took off. And as it went off, I'd seen these launches before, and this one kind of had yellow flames kind of flicking on it. But I thought, well, it's probably because we didn't build one of those big acoustic chambers, and that's the reason. We're getting these pressure pulses, And the booster's going up, and the booster's going up, and the Senate people are oohing and ahhing, and then it went black. The screen went black. So they said, what happened? I said, well, I guess we lost the feed. Later, I did call there and found out what happened. What happened is that the booster went up, 1,000 feet or so? About a mile. About a mile at that height. And stopped burning. And then just sort of, because they launched it vertically, it just kind of came right back down. Now, it did have a payload in it, which of course I didn't know about. Elon, being the guy who always believes that ask for permission, ask for forgiveness, right, had put a payload on it. Now, this was a payload from the Air Force Academy, and it was on this, and they went looking for the payload, And the story goes, and I don't want you to say whether the story is not true or not, Gwen, because it's too good a story for the facts. You know, I mean, that they looked for the payload and they found it next to the carton that it came in on, with just a dent in it. They put it back in the box and sent it back to the Air Force. And for years, it was on display at the Air Force. But that was the start. That was the start. Next slide. One of the other major things we did, this was finding things in space, and we were pretty good in LEO, low Earth orbiting, but get to GEO, we really had problems of finding small things. And so we went building a space surveillance telescope. Now, this is a huge thing, but the whole technology is a mosaic CCD camera developed by Lincoln Labs. And that was a focal plane which was curved. First time ever that a focal plane was made that was curved. And because it was curved, they didn't have to have that big optics at the end which planarized the wave so that it came down and hit a camera which was normally flat, you know, which is flat. Allowing it to have a larger field of view and allowing it to be very fast. And so we ended up being able to, projected that we could see very small things at GEO. Now, the telescope was built, it was put in White Sands, and actually demonstrated its capability. It's now been moved, or is being moved, to Australia. For what reason, I never could figure out why we just didn't buy another one and put it in Australia. Yeah. Next slide. The program that really did not go very far, although I personally felt that this was, we were talking earlier today about things that disrupt the system. This was a program that I thought really disrupted the system, and that, why do we send up a satellite which has all the pieces it needs in one container? Because that makes it very hard. I mean, what happens is that if you've ever watched a satellite be put together, there's these harnesses that they have to make to hook everything up. And they actually have to get sometimes guys with very small hands to do this. I mean, it's a very manual thing. And if you really see what goes wrong most of the time, especially in testing, it's this harness problems that they have. And of course, if Moore's Law went on after a year and a half, whatever you had in that satellite was old times. So the idea was to break the satellite into pieces, functional pieces, and rather than having them in some material case, just have them floating around, and having them, and be sort of a Wi-Fi net in space, and have them transmit, because you get good data, right? And so this was a program that was started, and then of course I left, and the next 10 years started, and space kind of, its importance at DARPA did go down. Although it's coming back, and in fact the people in DARPA are now talking to something similar to this program, and I think after a while they'll realize this was the right program. Maybe. Well, once again, as I said, with the Vice President being interested in space, space once again has become very important to this country, and very important to the Department of Defense, and very important, of course. This gives DARPA once again the ability to go and do the things that they have always been wanting to do, because now they can actually go and do them. I mean, this is a lot of money that has to be spent to do anything in space. So for this session, we're going to talk about the future. And we're going to talk more generally about two areas into the future. The first area is up to GEO. Everything from Earth to GEO. This is kind of where we've been, and there's still a lot to be done there. So the question is, what is the future in up to GEO? But I wanted to especially separate space into two parts, which is up to GEO and then GEO and beyond. Where is the future going to take us on beyond? The moon? Well, we went to the moon 6 times, and somebody finally said, don't we have enough rocks by now? And of course, there are people talking about going to Mars. So I think we really need to think about what is the value proposition of doing this, because that's why we stopped really going to the moon. I mean, it was expensive as hell, and 6 times seemed to be enough. Now, there is a sci-fi book written in the 60s, I guess, called The Moon is a Harsh Mistress, where the people on Earth found a use for it. They made a penal colony up there. Rather than having people in jail on the Earth, they just put them on the moon. And all kinds of strange things happened because the people on the moon, because of the sixth gravity, used to launch things back to Earth using a railgun. And after a while, they got pissed off, and they were taking rocks and putting tin on them, and they were launching rocks at the Earth, and ended up winning that war. So I don't know. That's just... but, look, I'm going to shut up now, and I'm going to have our panelists. Who are just, I couldn't have three better panelists, okay? I have Gwen, Roby, Mike. These are really, really great people. And they really have spanned all of space in many ways. I'm going to start with Gwen. And Gwen, I'm an old guy, so old guys, chauvinism was an okay thing back when I was young. And Elon, by the way, is a great person. But back in my day, we always said that behind every great man is an even greater woman. And Gwen, you most certainly, Elon is a great guy, but you really are the greatest woman, and you're the one that we all know makes that company go. Elon comes in with his ideas that are crazy, and you ignore those.
I hope he's not watching.
And I'm sure he knows that, because that allows him to do these crazy ideas and not have to worry about somebody might actually go do them. So, well, anyways, we'll start with you, Gwen. You can tell us your story on how you've made SpaceX the #1 launcher in the world.
Thank you, Tony. I appreciate it. Wait, am I up?
Yeah.
So I'm going to talk a little past, present, future. And I'm showing videos while we do it, so hopefully you're not paying attention to what I'm saying and you're just watching the videos, because that's the best part of any day from my perspective. But I am going to tell you about the Falcon launch. Your story is actually very accurate. The payload Falcon sat was a Air Force Academy satellite, and it did come back in a pretty spectacular way, and it did land about a yard, I think, from its shipping container. And it was crunched up. It was more than just dented. There was more there. But it was on display at the Air Force Academy for years. I don't know if it's still there. But yeah, it was almost, it's a harbinger of reusability. Yeah, so we moved from Falcon 1. We actually could not make the Falcon market work for us. I think things have changed a little bit, and I certainly wish the little launcher guys success. But we had to move away from Falcon 1, and we moved to Falcon 9 and Falcon Heavy. We've been launching Falcon 9 since 2010, and we launched our first Falcon Heavy in February of this year. We've got 2 more Falcon Heavies to launch in the very near term, and we'll continue on launching out the manifest. This year we actually started to enhance and increase our national security space missions. We've won 3 GPS missions, and we just won a Falcon Heavy mission for the EELV community called Space 52, and we're excited about flying that. So we've been to low Earth orbit with both Falcon 1 and Falcon 9. We went beyond GEO with the Falcon Heavy flight. We've got Elon's Tesla, his Roadster, on a heliocentric path, which was a super fun mission. That was such a great day. Actually, there were many great days, but the 3 that I remember most are getting Falcon 1 to orbit, for sure, actually 4. Landing the Falcon 9 booster for the first time in December 2015. Birthing with the International Space Station was an extraordinary day for us, too. And then the Falcon Heavy launch. And I knew the Falcon Heavy launch was going to be spectacular, but how it captured so many folks' imagination, and how many tweets and pokes and emails and texts that we got with people that really started getting excited about space again. So all the Actually, all the criticism about sending a Tesla to space was totally worth it from my perspective. Yeah, I thought that was a great idea. So launches and landings, it's critical to our business. The final iteration, the final big iteration on Falcon 9, it's called Block 5. We've flown it 5 times. We've got another one on the deck to fly here this weekend for Telesat. This vehicle, this rocket, is capable of flying more than once. We hope to be able to get 10 or more flights from each of the boosters here. And that really changes our cost model for sure, and hopefully we'll be able to pass that on to customers as we go. But I've spent billions of dollars on this technology, so the price is not caving in quickly, but we'll get there as soon as I can. So besides just executing our manifest and continuing to work on Falcon 9 and Dragon, or Falcon 9 and Falcon Heavy, we've got a huge monumental task in front of us, and that is to fly crew again for the first time since Atlantis flew in 2011. This is a program that is so fundamental to why Elon founded the company. We want to fly people. We want to fly them beyond low Earth orbit. But certainly, we need to fly them to low Earth orbit coming up here in the relative near term. I always get nervous for launches. This will probably be the most nerve-wracking launch that I have, or that I will ever experience. But it's really important for us to be able to fly our own astronauts, and also as a precursor to the follow-on systems that we want to build. And that is a vehicle called, oh, sorry, I skipped ahead, but it's fine. We'll go ahead and watch this. Called the Big Falcon rocket and the Big Falcon spaceship. Spaceship is the second stage. It's fully reusable, just like our first stages are reusable right now. And there's so many opportunities, so many different ways we can use this system. But the one that I'm the most excited about is to be able to fly from DC to Spain in less than an hour, LA to Singapore in less than an hour, basically do my business overseas, leave in the morning, do my business, come back, cook dinner, and sleep in my own bed. That would be life-changing from my perspective. So I'm quite excited about that. That's just one possible use for this system, but fundamentally we're designing it to take people to other heavenly bodies. I think we'll go to the moon first, and then we'll head on to Mars. And I think that's not really even enough from my perspective. The thing that I get most excited about is figuring out how to go much further, much faster, and meet other folks that are out there doing interesting things like us. And I should have said this at the beginning, but DARPA was enormously helpful to SpaceX with the Falcon 1 program. It was actually the Falcon program, Force Application and Launch from CONUS. It was the Falcon, but we didn't name it for that, our Falcon. So we had your Falcon, we had my Falcon, and then we had a little Falcon set too from the Air Force Academy. So
That's a bunch of Falcons.
there's a lot of Falcons. Yeah, it's a good time. Thanks very much.
Okay, well, next is Robbie Schlinger. I'll learn how to pronounce that sooner or later. Yep. We met about 5 years ago at a breakfast we had in the Cosmos Club, and he was just starting off, and he was talking to me, and he just wanted my opinion about this small satellite type of thing, and told me what they wanted to do, and I said, hey, good luck, I had no doubt about the technical part. I mean, I really believe that the technical part was there. I was a little concerned about whether he could get the money to do this, because again, you had to find a reason for doing it. I mean, the commodity of imaging the Earth had to be worth money to somebody, and if there wasn't worth money to somebody, then nobody was going to pay to have all these rockets put up there. Now, I thought they were getting up to imaging the Earth in 1 hour. He tells me he's only up to 1 day. Which is not a Nyquist rate that's going to be meaningful to anybody. So you got to get up to an hour.
All right.
But anyways, but he's been extraordinarily successful. I mean, they're doing it today. He got the money. He got the money. And they're launching this. I mean, just amazing. It's absolutely amazing. And it is I know for the agriculture people, once a day is good enough. So there is a big benefit there, which will keep your business going. So go ahead, Rob. Now tell us, remember, you got to talk both sides now, up to GO and GO on.
You got it. Well, yeah, so last year we did, after 7 years in our company, building almost 400 satellites and launching 300 satellites on 21 successful launches do image the whole world every day. And it is at 3 meters per pixel, but it's a persistent monitoring capability. And at that spatial resolution, you can see economic stocks and flows all over the world with an unbiased, factual, spatially explicit information feed. And in order to achieve this, we really first focused on the space side to miniaturize the satellite, to figure out the engineering processes to take the latest chips and components from other industries, whether it's automotive or consumer electronics, and have it work and survive in space. Learn how to mass manufacture them, and then bake in all the sensors for autonomous operations. So today we have close to 200 satellites in space with about a half dozen aerospace engineers that are operating them. And it happens autonomously. And every month, our yield continues to go up as we continuously upgrade the software on board the orbital assets. And about once every quarter, we launch new space demos, testing new chips and components, adding more sensors and more capability into our satellites. And about once a year, we launch about 20% of an operational fleet, so that every single year, what we provide to our users and the customers is better than last year and backwards compatible. So it becomes infinitely upgradable, and it gracefully degrades by having a sensor network in space. So if we're talking about where the future is going in low Earth orbit and up to GEO, and I like how you were mentioning Heinlein and what we were doing in DARPA 15 years ago, 10 years ago, and so forth, is this is cyclical in our industry. And perhaps some of the best things that we can remind ourselves with are the academic research papers of the 60s and early 70s, when the rate of progress was just extraordinary. And at that point in time, there are many really interesting CONOPS, interesting missions that can be done with a disaggregated and a diversified sensor network in space. So I think Planet is operating one of those today, all in imaging. We also operate the Sky satellites, SkySats. We have 13 of those in space that are sub-meter, that can image anywhere twice per day, and another 8 that are going up in the next 12 months. But the benefit that comes with allowing yourself to take risk in one node of a system, and allows for you to strap Moore's law to space, essentially, and take greater risk with each step along the way, and making sure that you come up with a system that is resilient. We need that for security purposes, and we also want that in a commercial business to make sure that you can live up to your SLA, your service level agreement for your users. And if we think about the ways in which we use robots in space today, whether it's for imaging, for weather, reconnaissance, surveillance, to early warning systems, to PNT, to telecommunications, the similar type of architecture can work there with a disaggregated system that is upgradable over time. And I do think that is a bit of the trend. There will always be the need for specialty systems and exquisite systems, both for national security as well as for scientific utility. But with telco coming from GEO down a little bit more, decreased latency, again, a resilient system that can be continuously upgraded, that does seem to be a bit of a trend that's happening. And then as we go beyond GEO, if we think about the infrastructure that we need for habitable planets, we can look no further than what space infrastructure do we use today to inhabit our planet. Those similar types of sensors that you need, we'll also need them around the moon, and we'll also need them around Mars. And so these architectures are scalable to where we end up going as humans. And as we begin to think, the cost comes down for buying your own launch vehicle, whether it's the small launch vehicles or whether it's the Falcon 9 or the BFR. then you can take more risk because the total mission cost is cheaper, and then more actors can come in and do new things in space. We're seeing many new countries get into space today, and a lot of that is because of the CubeSat standard, which more or less just made the price to space free, because you go up as a secondary payload. But then as the price comes down, more actors will come in, and that's where there's a bit of an opportunity to think through the participation architecture between what does the space program do, what does NASA do versus what does India do, and what does SpaceX do, and Bezos. And so there is a rush to the moon again. It is a little bit more logical to go to the moon next. And so I do think in the next 10 years or so we're going to see some things that we haven't seen in a long time, and it's going to rejuvenate the community. It's going to rejuvenate the public, and with that, it's time to go back to the future to look at these space settlement architectures around how to do it with intentionality.
Well, thanks. You know, and we'll come back to this after we have Mike, but you know, going to the moon is a good idea. But unless we figure out what going to the moon does for us on Earth, it's just going to be, you know, now people talk about going and mining the asteroids, and that may be enough. But we have to find out whether there's something there that really comes down to Earth. Going to Mars, I know Elon wants to go to Mars, you know. And I'm sure we're going to go to Mars, but are we going to stay there? You know? So I really think we need to not make that mistake that we were so hell-bent, remember I'm an old guy and I was around, going to the moon, that we went to the moon and we said, well, we went to the moon. And wasn't that enough? We didn't think of what was next, okay? And I think this time, this is really highly expensive stuff we're talking about. And we really need to have people with a, you know, visionary of how I'm going to mine the asteroids, and I'm going to get some rare mineral there that I can't get here on Earth, where the amortizing all the cost of doing that is going to be worth it. Okay?
When the cost comes down for a full mission to be under $10 million,
yeah,
which it could with a small launch vehicle. If the Falcon 1E was still around, and if it was $6 million, then you could do that.
We only paid $5 for it, by the way.
Okay. But yeah, if that total cost comes down, then exploration will happen. People will find interesting things. Governments will still be there. Infrastructure will be set up. I don't think that we understand what the economics of it will be, so it actually won't be driven by short-term economics to begin with. It is going to be something that's more philanthropic. It is going to be something that's more of a unique public-private partnership around services. And I do want to applaud NASA for learning a lot from COTS and bringing that forward to what the procurements are coming up with for lunar activities.
But you know, Columbus didn't go to America. He was going to go to India, and that's why the Queen gave him all her money, all his money to do this. You know, there was some end point that they wanted, and he just happened to stumble into America on the way. He didn't even know it was there, right? So, anyways, we'll go on to Mike, and then we'll talk. We're going to have plenty of time. Mike Griffin, I mean, this is a guy who, you know, you look at his resume, and he really knows about this business. You know, he's been in all aspects of it. Every aspect of this business, he's been in it. And he has done lots of really great things. Now, I kid with Mike that he always wants to have the last word, so that's why I put him last. But you know what? Mike Griffin deserves to have the last word because he really does have the last word. Go ahead, Mike.
Well, thanks, Tony. Actually, who gets the last word will depend on who fields the last question. So that's not yet predictable. In being asked to think about what things look like over the next 60 years and what the future of space is, there are a couple of things that come to mind. Where we are with space today is, to my mind, analogous to where we were with open ocean voyaging when what we had was wind power. You know, Captain Cook's first voyage around the world, I remember looking up the statistics on this. It took nearly 3 years, and when he returned, he was praised for his exemplary seamanship, for the fact that I believe 69 of the original 103 on board survived. It's only 2.5 centuries ago, but we've lost touch with what exploration and the development of far countries was like with the technology of that era. So steam power came along, eventually better navigation came along, lots of different technologies converged to make sea power a real thing. The 150 years after Cook, conflict in World War I on the oceans was nothing like what it was in Cook's era. By the time another 60 years have elapsed, we will have been in space in one way or another for 120 years. It's getting to be a significant time. And so I think we will see, looking backward, looking forward, we'll see some real changes in how we think about space and how we behave in space as a result of technologies coming together. So what will those be? The no-brainer will be nuclear power and propulsion. The only reason that's not the case today is politics and the politics of the irrational. And if we do not grasp onto the rational, then other nations will, and we'll be watching it on TV. It's easy to make fun of going to the moon, as it was easy to make fun of Lewis and Clark's voyage or mission to the West Coast. I had the privilege of testifying a couple of times in company with Neil Armstrong, and I will unabashedly steal Neil's comment from one testimony where he pointed out that he was tired of the argument that, well, we've been to the moon, why do we need to go back? He said, that's like, saying, well, Lewis and Clark went to the West Coast, there's no future in this. The people of Seattle would probably differ. A couple of 100 years makes a lot of difference. And there is a real difference between showing up first and continuing to show up. The future of space exploration and space development, which is what's more interesting to me, will be written by the people who continue to show up. The rules and the standards and the mores and basic questions like, will there be property rights in space? Will there be a rule of law or a rule of man in space? Those will be settled by the people who show up and develop those assets, not by the people who stay home and write legal opinions. Other technologies. I think the key technology for the development of space is going to be to utilize resources in space. As long as, it takes twice the ideal delta V, 3 times the ideal delta V to get to low Earth orbit than it does to go from low Earth orbit to either the moon or Mars. As long as we try to drag everything up from the gravity well on Earth and then use it in space, we're going to be like the people during the California gold rush who were sending their laundry to Hawaii to be done. We're going to be disadvantaged. So when we start doing even the most basic things, and I would say that the most valuable aspect of returning to the moon would be able to extract liquid oxygen from the moon and ship it up to zero potential through 2.5 kilometers per second of ideal delta V versus 10.5 kilometers per second of ideal delta V. Oxygen makes up, even if you're just talking chemical propulsion and not nuclear, oxygen makes up 7/8 of the mass of the LOX hydrogen propellant combination. So if you never got any hydrogen from the moon, and we talk about using water from the moon, and we will. But if you never got any hydrogen from the moon, 7/8 of your problem would go away just by getting oxygen. And in the samples that we got from Apollo, 15 to 40% of the lunar crust, depending on where you are, is by weight can be oxygen. And then of course, it won't take us long to learn how to mine aluminum and other key things. When we start using extraterrestrial materials, whether they come from asteroids or from the moon, that will be one of the technologies that gets us over the hump. I'm fond of reminding people who want to talk about mining near-Earth objects that the moon is a near-Earth object. Other critical technologies will be directed energy, large-scale directed energy, by which we can collect power in space and beam it, probably not necessarily, in my view, to the Earth. We might, but we can beam it from place to place in space. That will be important, I predict, in the long run. We can get very tight beam widths with large apertures, and once we have improved the conversion efficiency of sunlight to energy power, being able to beam that from spot to spot in the same way that we use copper wire to send power from nuclear plants or oil-driven plants or hydroelectric plants from where they generate the power to where we want it, that will be very critical. In space, we won't have to use copper wires. So those are just a few of the technologies. The thing that I hope will, and hope is not a management tool, I do appreciate that, but what I hope will occur is that we as in Western society will recognize the truly strategic nature of doing all this. Because in 60 years, it will be impossible to imagine that any business can succeed without having some piece of that business dependent upon space. Some of this is true today. Nobody does a point-of-sale transaction without space resources. If the GPS timing signal goes away, so does your ATM card. You know, it'll be nice to have gasoline in the ground at gas stations, but you're not buying it because the pump won't work, and so on. In 60 years, I believe that it will be essentially impossible to conduct any significant Earth surface activity without utilizing in some fashion capabilities delivered through space or from space. My fondest hope in all of this is that we are demonstrating that lesson to others rather than having it be demonstrated to us by others. And with that, I'll stop for now. Thank you.
Mm-hmm. Good. I don't think there's any disagreement that activities in space that benefit people on the Earth are going to happen. You know, they're just going to they happen now, as you said. They're going on. We can't. I mean, GPS is a good example of everybody here in this room depends upon it. You know, we don't even think about it, but they depend upon it. I'm a great reader of science fiction. I've always believed that science fiction writers are really good inventors. They take a few facts and they make a story out of them, you know. And that's what I'm looking
Sounds a lot like the Pentagon.
a little bit. but that's kind of what we need to do. And I'm trying to get, okay, well, there's a few facts, and you've mentioned quite a few facts. And it'd be great to get a story about those facts where we have to add on other things that make it all come together. I would recommend anybody who wants to read about leaving the Earth and going, there's a science fiction series called Expanse, E-X-P-A-N-S-E. It's great. Get the books. They're huge. It really is, people leave the Earth, and they go and they actually colonize moons of Jupiter because, and all of that. And then you end up having two kinds of people, those who are born in zero gravity and live in zero gravity or very low gravity, and they turn out to be different people than live here on the Earth. I mean, physically, different people who live here on the Earth. I really recommend that you go and get those books and read it, because somewhere in there's a story as to why we really want to do this. I mean, there is a story there, and it's clear the story of feeding back on the Earth. That we're going to be in space, no question about it, and especially since the people here on this world depend on it a lot. It's what happens when we move out. We've really got to come up with, why do I want to go to India, from Europe? What was it that I was after that I thought was going to be there?
Well, if you were the second son of English gentry and the title on the land went to the older brother who stayed at home, then you went to India.
Then you went to India. No, exactly right. Exactly right. That's how my grandfather came to the United States. He was the second son of an Italian family, and he wasn't going to get the ranch, so he came and worked on the railroad. Let me see what we have here from the audience. Maybe they have better things to say. Meanwhile, anybody else have anything to say while I go through these questions? I mean, Mike made a lot of good points.
He always does.
Yeah, that's why we had him last. Yeah.
I can get this at home. I don't need to come here. I mean, really.
Oh, here's one. I mean, this is it. We get into some of these questions, which are we have to answer. With proliferation of CubeSats, blackjack, etc., how is this going to impact the space debris issue, and how is this being dealt with? Who would like to take that on?
Yeah, I can go first. So, and then I'm sure Mike will jump in. I think it's going to accelerate the community to get together to come up with a space traffic management system and an open SSA approach, because we're going to need it. There's going to be a lot more things up in space. Space is big, but there are a number of ways in which we can mitigate collisions. There isn't an unobtainium thing there to do it. It's really a matter of how do we govern it, how do we set it up. Are we, from a national security perspective, are we okay shifting our posture with respect to SSA to make that more open? And if we really do want to open up to extend the economic sphere of influence into low Earth orbit, going up into GEO, then there needs to be some rules of the road for commercial actors in order to access space and utilize space in a sustainable manner. So, open SSA, getting to a space traffic management system. Then there are easy technologies in order to mitigate the debris problem. But it still is a challenge, right? We're in a Kessler syndrome. We have to do some major things with some big things that are up there, and there are some technologies that people are working on to try to be a tug and go pull them down, or to do nudge it with light force or with a ground-based laser in order to avoid conjunctions. But yeah, hopefully with the proliferation, then we will accelerate a little bit further as a community in order to get toward an STM system.
But I do think it's important. We'll come up with ways of managing the junk we've put in orbit up till now. And hopefully we will be good stewards going forward and don't put anything up that is unnecessary to be a piece of space junk. And that as we put up satellites, we ensure that we have the capability to bring them back when their life is over. And some of the stuff you can't if you have a failure on orbit. But again, if you want to fail and re-enter, feels like a good approach. So there's lots of ways to do it, but I don't want it to be so easy to manage the problem that we stop creating more of a problem.
Mm-hmm. A lot of the questions are really for you, Mike, and they're all in this same different ways, but they all ask the same question. How does the proposed Space Force? Oh, you knew this was coming, right?
Sure, I did. I absolutely did.
Change the way that we realize our future in space. Do we need to align civil and military needs?
Well, with regard to Space Force, let me make a couple of prefatory remarks, and then we'll see where that goes. And I'm sorry if I'm slightly long-winded. I'll try not to be. Space has become, there are several reasons why we should have a Space Force, but among the most important to me is that space has become so strategic for the United States and for really the world, but especially for the United States and our Western allies and partners. We use it for economics. We use it to fight through. We will be using it to fight from, like it or not. It has become and will be more of a warfighting domain. No one is looking to do that in ways that create additional debris. Everyone is sensitive to that, but space will be a warfighting domain. It already is. We did not choose to do that, but the adversary gets a vote. If the choice before us is to respond or not to respond, and that was a point made by John Hyten a month ago when he and I were speaking at SMDC in Huntsville. And John's point was, well, yes, we're going to respond. Sometimes the United States is a bit slow to respond, but we will respond. The best way, in my view, to craft that response, and equally importantly, to allow our adversaries to understand that we take this seriously and are responding, is to coalesce our capabilities into a Space Force. Not all of my colleagues in the Defense Department agree with me, and that's perfectly okay. We're still friends, but I believe that we should do that, and I believe the President is on the right track with that effort. The geopolitical message that it sends is the most important single part of it. How will things be different? I believe that we will put our adversaries on notice that the United States' capability to project its power where it needs to be projected will, in space, become exactly the same as that we have enjoyed in our role in air dominance and maritime dominance now for decades. We will need to demonstrate to potential adversaries, so that they do not become real and present adversaries, we will need to demonstrate to them that the best way for them to avoid problems is not to start a war. And space dominance is key to that. It's as much a part of deterrence as it is about power projection. So I think that will be the major way in which the Space Force will change our thinking. It will send a message that I deeply believe needs to be sent.
Okay. Thanks, Mike. The one question is, I guess, for all of us, and it really is looking at SpaceX and saying that we seem to be stepping towards having an airplane-like capability that takes off, flies to space, comes back down. And I guess what brought that question on was you're having a airplane, which is a vertical launch airplane, fly over to another country and land in a vertical way. And do you see that as being just a step towards having something which is more like what we are used to, about having a horizontal launch, going to a booster type of approach, going to space, maybe dropping something off in space or picking something up in space, and then coming back and landing? So where do we think that, and you know, we've tried that technology many years, and we're trying it again. You know, some of the hypersonic stuff of having one that actually generates thrust at zero velocity and can go all the way, and maybe go all the way and fly off into space like we tried back in the early 80s. But that seems to be a natural next step. What do you all think about that? I mean, is that, or maybe just launching vertically and going is the same thing? Maybe it's just, maybe we're just used to airplanes and not used to taking off in a booster.
Well, every time we've done a study on vertical landing versus horizontal landing for reusable vehicles, it turns out to be a pretty close trade between the weight of the propellant to land versus the weight of the wings. So I'm personally believe that it can be done either way and probably will be done both ways. All of you who know me at all know I'm addicted to numbers. So 20-some years ago, I wrote a paper with Bill Claybaugh looking at the economics of reusable launch vehicles, and at a certain flight rate, it becomes economic. But that if you have the technology for a single stage to orbit, you actually are better advised economically to break it into 2 stages. I gain more from the staging than I lose from the complexity of the integration. So my prediction is that in this next 60 years, we'll see 2-stage to orbit, largely reusable systems evolve. I think reusability can be overdone. Nothing is completely reusable. Every time I have to have a repair done on my sports car, I'm reminded that nothing is completely reusable. So there's an economic point at which you may choose, not to continue to fly that airframe anymore. And as the more experience we gain, the more reusable it will become. I'll point out that we're in the infancy of sailing in space, and I'll point out that Magellan's ships were not reusable.
That's right, they weren't.
I mean, we have an awful lot of technology in front of us. We think we're better than we are. Where we are is we are at the Viking longship era, where human beings were just learning how to venture out of sight of land. That's where we are.
Mm-hmm. Of course, 60 years is a long time, too.
60 years is not a long time in the sweep of human history.
No, but in the pace that we're on today, it's a long time. I mean, a long time in the sense of what could happen in 60 years. What do you think about that? When you actually have the opportunity with what you're doing to actually fulfill your dream. Do you have on your drawing board when you're going to take passengers from here to?
So, I mean, I do think taking people to the moon and to Mars.
No, I mean Earth to Earth.
Oh, Earth to Earth. Oh, yeah, that's great.
Yeah.
But I mean, that'd be great.
Oh, that.
Can't wait. I'm flying to Madrid tonight. It'd be great if I could be back tomorrow. Yeah, and that's just a little piece.
Yeah.
I mean, that's just kind of a residual capability of building a 2-stage, reusable first stage, reusable second stage system, is you can do that. I'm not saying that there's not hard work and hard engineering to get done and operations to get done. There's a lot of technology that we need to work on to do that, but we're pretty focused on it. And yeah, I think we'll be hopping that second stage next year, late next year.
And what do you see economically? Because you are a business, right?
We are that.
Yeah. So what do you see economically? I mean, it is great to take an hour to go halfway around the world.
Yep.
I mean, that would be,
Great.
I don't know how many people. I don't know how many people actually do that, but I'm sure that if we had the capability to do that, a lot more people would do it. So have you done any back of the envelope, kind of what do you need, what does it need to be, I mean, because
We're building the system regardless because we want to take people to Mars ultimately. So it's similar technology. But if you look at, we've done back of the envelope calculations, and I think it's an expensive economy, or a relatively inexpensive business class ticket price. I think that's where it's going to end up. I think if you think about the management of the system, because right now an aircraft goes overseas, it does that, can only do it once a day, or a trip, one a day, maybe 2, but I think mostly 1. Whereas this ship, with largely the same investment in the airframe and the capability, not the non-recurring investment, but the recurring cost, roughly the same as an aircraft. Rockets are roughly the same. And if I could fly that airframe, or space frame, I guess it is, if I could fly that 10 times a day or 20 times a day, I could make a lot more revenue from that piece
Sure.
of hardware.
But of course that means that when you land in Singapore, you have to have all the facilities there to be able to do it again.
And you
right?
design it such that you don't need a huge infrastructure to land and go.
Land
Land and come back, or land and go to the next place.
Well, every transportation system has an infrastructure that has to be built to support it.
Yep.
I mean,
It just depends on how much engineering you do to make it
Yeah.
as,
but I mean,
Minimal as possible.
you wouldn't have air transport without airports, air traffic control system, you
Oh,
know,
absolutely, it's
deliveries
required.
of Jet A.
Yep.
I mean,
yeah, I'm not saying no infrastructure,
Right.
but you want to limit the infrastructure.
Sure. Okay. Robbie, what do you have?
About space transportation?
Huh?
About space transportation?
About anything. I mean,
About
you're planning on making money at this. You know, you're
Yeah.
And so is Gwen, by the way. She's planning on making money on this too.
I make money.
Yeah.
regrettably, I don't. Just to be clear here.
Well, I think that it is important to, you know, to close a business case and to not go too far out or a bridge too far for what you want the world to be like, and to be more pragmatic with where it is today, right? And, you know, that's part of the challenges that I have with some of the space mining stuff, is because it's a pretty far bridge. And I think, you know, learning from Gwen and Elon, you guys have done an amazing job in keeping sight for a North Star, or a red star, I guess, and being very pragmatic around each step along the way in order to do it. And in order to get that next step, you end up creating more capability, which then builds momentum. And I think that you see that again and again and again in other successful businesses. So there's nothing special about space when it comes to for a business. You have to, you know, have that pragmatism, but then also the audacity to think about changing markets and making markets. But it is also to meet the market for where it is today. You know, so if you look at Planet, we're indexing the whole world every day so that anybody can search it. But nobody knows really how to use that today. So we license a whole bunch of data to agriculture firms and to governments, meeting the market for where it is today and being a market maker for how to use AI, how to use automation, how to use these tools to change your workflow in order to then bake it in. And all while creating that capability, we keep investing in the next sensor and the next thing and the next capability. So it's, I think that it is important for there to be really good entrepreneurs in our industry so that we then have reliability, and so that then we end up having a market. So you don't have to be completely vertically integrated, and you end up specializing a lot more. And I think that we're realistically very far away from that.
Mm-hmm. Okay. You know, one thing first of all, SpaceX, I think you've done a tremendous job. By the way, the program manager at that time was Steve Walker, just in case you wondered who was the...
He was sitting right over there.
Did he leave? They took him.
He got disgusted and left.
And I remember when we were doing this and Elon bid on the Access program, and Steve told me, he said, we got this guy, you know, he did PayPal, and he wants to build rockets, you know. So I said, well, okay. And he only going to charge us $5 million for the shot. You know. So I guess I need to talk to him. So he came in, and I said, Elon, why do you want to do this? I mean, this is a hard business. You know, you're going to have to launch 19 successful shots out of 20 before anybody's going to use your booster. You know, it's just, that's the way these people are, you know. You know, they just got to have that kind of a percentage. And he said, I have always wanted to do this from when I was a child. I've always wanted to do this, go to space since I was a child. And that's what I want to do. And that was his rationale. Nothing to do with, you know, he just wanted to do it. And I said, okay, we're going to let you do it. because you're going to do it without us. We might as well come with you for $5 million a shot, you know? But you really have done a great job.
Thank you.
And Robert, you've done a great job, too. I mean, 5 years to have that many satellites up. You need a faster Nyquist rate, but you'll get there.
We'll get to hourly sometime.
Yeah. And Mike, thank you very much for everything you've done for this country on getting us to where we are today. So let's give them a big hand.